These people don't know how to operate. Very hard. What's that? Students, they play in the school. They're getting very loose. My phone is still probably broken. Who came in online? Online, sir, only me. I spoke to Aditya. Who is Ramesh Bollu? New student. Your name? Hello? Your name, yaar? I think girl, not responding. In volume 3, all topics covered. Maths? No. Volume 4. I think I had already notified when I came here. Straight line. Oh, okay. You're saying volume 3. 411. One covered already. So volume 4 is not required. A lot of mistakes. Best choice. He's ready. Like, how long is this finished class? Sir, I already finished in time, sir. Hey, Jiva. Soda. But 2 minutes. Everyone,
Yes, sir.
2 minutes, please. Some offline students will join soon. We'll start. short. After this, 3 by 4, what is equal to 4 by root 3. What is equal to 4 by root 3. Let's take it from y. I think area is equal to 1. Show me the. There is one more rule, right?
Sir, his friend came for admission.
Okay.
He said you go and come.
He's talking commission, huh?
His friend is saying, anyone please be with me. Like that he's saying that.
Okay. So very good evening, everyone.
Good evening, sir.
Good evening. So in the last session, we were talking about energy, no? Someone please tell me what is the energy, average energy density? I forgot the equation. Someone please tell me.
Average energy, sir.
Yeah, average energy.
Half mu a square omega square lambda.
Yeah, average energy density stored in string. Stored in string. How much? D is equal to how much? D by dx. Average density means total energy stored in 1 centimeter length. Understanding? Okay. That value how much? Half into how much? Mu into amplitude whole square into omega square.
Lambda, sir.
That is the average energy stored in one full wave. Okay. When average energy stored in 2 full waves means 2 lambda you have to multiply. Okay, that is the concept. Now here I want to find the average energy density stored in volume. This average energy stored in the string. There is no rule that only waves should propagate in the string. Sometimes waves also propagate in the rods also. Rod means very wide wire. The wire with the largest thickness also it will propagate. In that scenario, what I have to do? For suppose I am taking one rod of length how much? Dx and area of the circular cross section how much? Capital A. So on either sides, what I will do for rods, when wave is propagating in the rod, what I have to do on either sides, I am dividing with the area of the cross section and area of the cross section.
Okay, sir.
One small alteration I will do. Amplitude A term I am using. A letter I am using. So here the area of the circular cross section I will use different alphabet S I will use. So on either sides I will divide with S. So what I can get? D by S into dx, and here also half into mu divided by area of the circular cross section and into a square into omega square. For a while I will keep aside this is equation number 1. Now when the rod is concerned, when the cylindrical elementary rod is concerned, what is the mass density? Rho is equal to? Mass density is nothing but total mass of the element by volume of the element. What is the volume of the cylinder? S into length of the element. You know what is the length of the element? Mass by length is nothing but mu. Very good. Linear mass density. So I can also write rho is equal to mu divided by S. So in the place of mu divided by S, now I can replace with the mass density or mass volume density. Okay. So here I can write energy density. Average energy density. average energy, or if you need to get more clarity, energy volume density also I can write. Energy volume density also you can write. Volume energy density also you can write. So I can write here total energy stored in 1 unit volume equal to how much here? Half into rho into a square into omega square. Wherever I am keeping star mark compulsory, you people have to remember, because your JEE mains perspective in intermittent calculation, you have to apply directly. Understood? If you don't remember, unnecessarily lot of time will be wasted. This is the average energy density, very easy to remember also. Average energy stored in string equal to mu will come here and here rho will come. And one more very important parameter during the wave propagation is power of a wave. What is that? Power of a wave. Power of a wave. Power of a wave. Somebody define what is power? Power is nothing but total energy consumed by wave in 1 second. Correct or not? If you have high power means what? Two cars are there. One car is powerful, one car is low power. What is the meaning of that? Tell me. It will pick up some 0 to 50 kilometers 10 seconds. Another car will pick up 0 to 50 kilometers per hour in more than 10 seconds. Correct or not?
Yes.
So power is nothing but rate of consumption of the energy or rate of doing work. So here I can write total energy. What I can define? Power of a wave, what we can define? Total energy stored in the string. What is that? Total energy stored in the elementary string in 1 second. The total energy consumed in 1 second is defined as power of a wave. What wave is considered? Transverse wave in a string. Or for all waves. Transverse waves in a string I am analyzing right now. You people tell me what is the average energy? Watch this equation. Average energy is nothing but the length of this elementary string. I have to take that side. So what I will get? Power equal to half into mu into a square omega square into dx and whole divided by dt. Tell me what is the length of the element divided by time taken? Velocity only, no? So what I can write? Average power equal to half into power means I don't need to specify separately average power. Speed means average speed only. Velocity means average velocity only. Power means average power only. So the general symbol for the average power is like this. So average power of a wave equal to how much? Half mu into a square into omega square into total distance traveled in 1 second by the wave is nothing but velocity of the wave. This is the most important expression for what? Average power of a wave. Name alone we are using wave, but we completely consider the elementary part of the string only. For a small element is concerned, the power of the element same as power of the wave. Is my point clear? So that is a very important equation. And now, what about for? This is applicable for only transverse wave when they are propagating in the string. Then what about the longitudinal waves propagating in the rod or waves propagating in the water or liquid or gases? Very simple, mu become rho, that's all. Correct or not? Here also mu become rho, no?
So here also what will happen? Mu become rho. So I will derive that also. The average power of a wave is concerned.
Wants to listen. They have some ask with this. Science students. Okay, you also. Okay.
So now here, if you consider any longitudinal waves, for example, longitudinal waves in a rod. This is any metal rod. When you tap this side, so the sound will propagate in the left to right direction. Let's say the density of this rod is how much? Rho. Let's say the area of the circular cross section is S. Tell me now what's the energy stored in this elementary rod? Shall I use this equation?
Yes, sir.
I can use this. So what I can write? Energy stored in the complete elementary rod D is equal to how much? Half into rho into A square into omega square into how much? Total volume of the element. Okay. Tell me what the volume of this cylindrical element? How much?
The area into
Very good. Area of the circular cross section into the length of this element. Okay, so I can write area of the circular cross section into delta x or dx. Now we are discussing about the power of a wave. Power means what on either sides? Divide with the time. Here also divide with the time taken. What are distance traveled by wave here also? Distance traveled by wave in 1 second is nothing but velocity. So here also, when the average power, if you consider that equal to half rho into a square into omega square into s into velocity. This is the average power stored in a longitudinal wave. When longitudinal waves like sound waves are propagating in the rod. Okay. Now, another term, intensity. How can you define intensity? Tell me. Intensity of a wave. You have some intention. For example, intention of studying. What is the meaning of intention of studying? Having intention means having the ability to study or to learn something. Here also intensity of the wave means ability to drag the energy momentum from one place to another place. Understood? So how can you define the intensity? You can define the intensity total energy stored per unit area in 1 second time. How can you define? Every wave has some energy now. With the use of the energy, by using the energy, what is the role of the wave? Right now I am talking. I am delivering momentum as well as energy. Who is dragging that energy and momentum? You want to continue till here? Okay. Now you will not understand this. Okay.
Thank you, sir.
So here the total energy means I have the wave is having intensity. Intensity means it has the ability to drag the energy and momentum from one place to another place. Right now, actually, what I am delivering, my energy and my momentum. Yes or no? Who is taking that energy and dropping in your eardrums? Who is doing that job?
Wave.
Wave is doing the job. Means definitely that wave should have some energy per
Unit area.
1 meter square or unit area in 1 second. Is defined as intensity of the wave. For example, I am there and one loudspeaker is there. Who has more intensity? Definitely loudspeaker only. It will deliver more amount of energy on 1 meter square in very less time. But I cannot shout like speaker, no?
Yes, sir.
Correct or not? If a speaker, if you switch on around 2-3 kilometers, you can listen. Correct or not?
Yes, sir.
Okay, but if I attempt that, will I be alive?
No, sir.
No, not possible.
More
Why?
amount of
Because
energy is
yes,
required.
that's what. So different sources of the sounds, different sources of the waves are classified based on the interesting property called intensity. Okay. Now, as per our discussion, two different intensities we will discuss. For transverse wave, in the strings we'll talk. Okay. Tell me, what is the energy of the transverse waves? Tell me, D is equal to how much? Half into mu into A square into omega square into length of the string.
Yes.
Understood?
Yes, sir.
But I want intensity. What I should do? On either sides, divide with area of the circular cross section and area of the circular cross section. So here I am dividing with area of the circular cross section. Here also area of circular cross section. And here I am dividing with P. Here also I am dividing with the time taken. Tell me, what the distance traveled by wave in dt seconds time is called? Very good. Velocity of the wave or speed of the wave. So I can write intensity of the transverse wave equal to how much here? Half into what is this? Mu by area. Respond. What is the mu by s? Just now we discussed it. Linear mass density. I erased that. You know, very good. Bro. Remember this point. Remember the term. The ratio of the linear mass density to the area of the circular cross section is called volume density. Mass volume density. So I can replace with the rho a square and omega square and into velocity. So in the future applications, I will not write the all constants. Why? Because here density is constant, amplitude is variable. For example, one small loudspeaker you take, one large loudspeaker you take. What is the difference?
That's more amplitude.
Only amplitude only. Frequency remains same only. One singer is singing. Small speaker, same person is singing. Large speaker also, same singer is singing. Na? He has same frequency. So frequency constant, speed of the sound wave constant, amplitude is only variable. Density of the medium is always constant. Na? So I can remove all the constants. I can replace with the single constant. So I can define intensity equal to how much? K into A square. In the oncoming future applications, it is a very important term. Directly, me and you, we are going to apply it. And this intensity and amplitude relation in vector addition also directly we are going to apply. Okay.
Sir, what is that value of K?
K is equal to half rho A square omega square.
It does not have any constant.
It depends on the density of the metal, density of the medium. It depends on the frequency of the source. Correct or not?
Yes,
I have different frequency, you have different frequency. The language of physics, now you are a source of sound, I am a source of sound. Hamish will recognize different sounds now when both of us speaking. And he will recognize you have different frequency, I have different frequency. So source to source, medium to medium, this K changes. K is a function of a medium and a source.
Sir, then frequency, how we are saying it as constant, sir, because it is changing, no, sir.
Right now,
From you to me, it changes with different frequency. How we can consider frequency as constant?
see, I am a speaker, but I am appearing in two different loudspeakers. One is small loudspeaker, another one is large loudspeaker. Now tell me which is same, which is different. Amplitudes are different, intensities are different, but frequency is same only, na? In small speaker I am only talking, in big speaker also I am only talking. So frequencies are same only, na? Are you understanding?
Yes, sir.
Now in two speakers, two different people are speaking. So in that case, frequency also changes. So situation to situation, anything can be constant, anything can be variable. I am talking only here speaker, I mean source of the sound, I am keeping constant. You understand? Okay, same frequency, sources will take. Clear? In the future applications, we are going to discuss interference. For that, I will take two flutes. Two flutes, their dimensions are slightly different. Means they have almost all same frequency only, na? Correct or not? But one is big flute, another one is small flute. Which, so length changes means amplitude changes. Big flute will produce louder sound. Small flute produces feeble sound. You're understanding? Clear now? Why we are using this 4 LED lights? Room is big. Room is big. So you need more intensity. More intensity. More space means more intensity is required. Now very small room is there. One light is enough, no?
Yes, sir.
Correct or not? So situation to situation, the intensity affected. Frankly speaking, all are affecting factors. But when I am talking equal frequency sources is concerned, amplitude only changes. Two flutes I am taking, na? That is flute, this is flute. Both are producing almost all same frequency only. It has 4 holes, it is also having 4 holes. Both are producing same frequency only. But where is the difference? Intensity point of view different. Correct or not? That's what I is proportional to A square. Is my point clear? Okay. Now, we'll see one more situation. Is the time now?
37, 35.
So just I will introduce. It will take 20 minutes time actually for finishing this. Just I will introduce. For example, this is one string is there. What is this?
String.
String, and this is one rigid boundary like wall or metal, etc. Right? Now this is my origin. This is my y-axis, and this is my x-axis. I am selecting one point B at a distance x meter. I plucked this wire for one oscillation. One plucking means what? One plucking means, see my movement of the finger. It will go like this. Again, it will come back to same position. Again, equal distance it will go. So this is called one plucking.
Yes, sir.
I plucked the string like this. In a fast movement, I will pluck like this. You understand? Means one wave is okay. Half oscillation made for better clarity.
Yes, sir.
So half wave is propagating through point P. Tell me the equation for it?
Y is equal to.
What is the, this is called instant wave only, na?
Yes, sir.
Here somewhere you plucked, it is heading towards the rigid boundary.
Yes, sir. It's right.
That is called instant wave. So what is instant wave? Y1 equal to how much?
A sin omega t minus kx.
A1, amplitude A1.
A1 sin
Very good. Sine of
omega 1 t
omega t minus
kx.
K1 into X. Two media are there, na?
Sir, then
This is first medium. This is the
second medium.
second medium. So K1,
K1.
K1 is for first medium. K2 means for second medium. Medium to medium wavelength alone changes, no?
Yes, sir.
Correct or not? So that's what only K1 I changed and A2, A1 alone I changed it. Now, if the wave is falling on the rigid boundary, what will happen?
It
Some
again
energy,
reflects,
some energy absorbed by the rigid boundary, and it will go like this. This wave is called a transmitted wave. What is the name of
sir.
this?
It will not be reflected down.
I will come to that point. Correct only. Some energy spreaded into the rigid boundary, some energy reflected back. Correct only. What you said correct. That is only the wave.
Yes, sir.
You are understanding?
Yes, sir.
So some energy transmitted into the rigid material. Tell me what is the wave equation? Y2 equal to?
A2
This
sin
is called incident wave equation. This is called incident wave equation. Then what is the transmitted wave equation? Transmitted wave equation. How much Y2 equal to? A2. Amplitude is different now. A2 into how much? Sine of how much this is?
omega t minus
Omega t.
minus
Very good.
K2.
Minus K2 into X. Originality will not change, na?
Yes, sir.
Here, for suppose SP Balasubramaniam is singing, same song you will hear, na? Means frequency
Same
same only, na?
frequency. Yes, sir.
Correct or not?
Yes, sir.
In this room, Balasubramaniam is singing. I am in another room, different gas medium is there. I will hear Balasubramaniam song only, na?
Yes, sir.
Means frequency same only, na? Means once wave is changes medium, frequency unaffected. I'm telling that. That's what in both of the cases, omega, omega, I did not alter. Is my point clear?
Yes, sir.
Next one. Next one. Some wave will be bounced back, na?
Yes, sir.
Here one mistake I have done, whether you noticed or not. Same point X only we have to take, na? So what I will do, this point I will shift here. That's all. Point P, I will shift here.
Why, sir?
Why? Because at this point P, we are going to investigate the interference between incident wave, transmitted wave, and reflected wave. Correct or not? If I do not change this same position means, so you cannot analyze the interference. Correct or not? Interference means the waves must confine at same position only. Yes or no? That's what I shifted this boundary. What I shifted? At boundary, which is separating two different media, I have shifted. Now, as you told, Jiva told already, sir, some energies bounced back on, sir. Correct? It will bounce back. What the name of that wave is called? Very good. Reflected wave. How will you write the reflected wave equation?
Sir, same amplitude, sir.
How will you write?
A1, same amplitude.
Yes. Reflected
Minus
wave
A1
equation
sin.
Y3 equal to not same amplitude.
Minus A3.
It is different.
Can take it as A3.
No, it is different.
Minus A3 sin of kx minus omega.
Very good. It will be different. As I told you many times, any wave, it is bounced back from rigid boundary. What will happen? It will become inverted.
Yes, sir.
So what I have to write here?
Minus A3
Minus A3.
sin omega t.
Very good. Sin.
Omega t.
Very good. Omega t.
Plus K3x.
Shabash. Plus
K3x.
no. K1 only, no? Again, it came back
Same
to the
medium,
same
okay.
medium, no? K is considered medium, Himish. K equal to 2 pi by lambda, na? K representing the medium. So here K1 must be written same only. Understood? So that interference, if I start, it will take half an hour. So your time up. Will discuss the boundary condition. Actually, this heading is title is boundary condition. Tomorrow at this point P at the boundary, we will study the interference for these three waves. How many waves are interfering right now?
3 waves.
Incident wave, transmitted wave, reflected wave, interference. Tomorrow we'll talk by using superposition principle. Okay, they are called boundary conditions. By analyzing the boundary conditions, okay, so we can distinguish clearly what is rigid boundary and what is free boundary. Some conditions we are going to deduce tomorrow session. Okay, thank you. Now take break.